Hello there, this is day 11th of grinding Leetcode. This is a series of video where I grind Leetcode easy problem in under 15 minutes. If not, then I will look at the solution and try to figure it out. But yeah, let's go ahead and randomize the question and get ourselves an easy Leetcode question to solve under 15 minutes. Okay, we got one right here. So let's see, how many number are smaller than the current number? So with these leak code question, I always find it easier to look at the example and figure it out before I read the text. So that's what I'll do. Looking at the title here, how many number are smaller than current number? So it looked like we are finding the number that is smaller than the current number. Okay, so let's see, the number input is going to be 81223 and the output is 40113. Explanation for number 0, 8, there exists four numbers smaller than it. So 1, 2, 2, and 3. For number 1, does not exist any number smaller than it. For number 2, there exists one smaller number than it, 1. For number 3, there exists one smaller number than it, 1. And so on. Okay, so this looked like a very easy question to solve. Um, the question is, do I want to do this in open square time, or is there a more efficient way? So how I'm going to solve this is that I'm going to loop through the array once, right? And then I'm going to take that number and compare it with every single other number. And while I do that, I want to keep a counter. If any of the number is higher than the current number, then I'm going to append that to a new array and then return that array. So this is going to be an O and square operation. Um, Afterward, I'm going to see if I can make it more efficient. I can probably sort this array, and if I sort this array, then I just have to return the index. So if I sort this array, then that become 4 at beginning, 4, 5, 6, 8. So if I sort the array, hmm, if I sort the array, then if I store everything inside of a hash map and sort this array, I can look at the number 6 to see where it's at in the hash map, and I can return the index of it. So I'm going to do that actually. I'm going to do for I in hash map equal to this for I in nums for n in nums. Okay. Well, actually, hmm, if I do that, then I'm not gonna have. There's two here, right? There's two here, so that doesn't really matter. No, it matters. If I sort the array, then the number that's corresponding to the array is gonna be the return output. But I still have to return it in this exact order. How do I maintain order whenever I do that? Hmm. And I don't want this to be an open square operation. I want to be faster than that. So I can sort the array. I'm going to loop through the array and figure out. Um, no, I'm going to sort the array first and then figure out, and then I'm going to put all of it inside of a hash map. So the sorted, we're gonna hash map is contain the sorted array index of each number. So I'm going to sort this first, right? So I'm going to sort this first. This array is going to be that, and when we're done with it, it's going to be 4, 5, 6, 8, right? And then we're going to store the index of it, the index of the new sorted array inside of a hash map. So that's going to be 4 is 0, 5 is 1, 6 is 2, and 8 is 3. So if I do it, if I loop through the first array again, I just look for number 6. Number 6 is here, and number 6, we found number 6. Oh, 6 is 2. We're going to return that. So that's what I'm going to do. I'm going to sort the array first, and then put all of that index inside of a hash map. And afterward, I'm going to loop through the original array, and then append that to a new array, and then return that. So that's what I'm going to do. Let's see, for I, well, how do I do a sorted array? So sorted R equal to nums dot sort nums. Print sorted R. Run it. That should work actually. Okay, so the sorted R is empty. Sort. Okay, Python how to sort method. Sort. Yeah, that was right. So sort. Okay, that is not gonna be. Oh, okay. Nums dot sort. Nums dot sort. And that should return the sorted array. Hmm. This is mildly embarrassing. Python sorted. Sorted. Okay, so it just sorted nums. Oh, there we go. So 1, 2, 2, 3, 8. Now we reprint num before we get sorted. We should get the original array. I was looking at the incorrect item. So yeah, so this the original array is unaffected. So now that we've sorted it, we're gonna put everything inside of a hash map. So for I in range of sorted R, length of sorted R, or actually, you know what? It'd be easier if I can do just for I comma for each for an n comma I in enumerated enumerate sorted R hash map at n is equal to I. There we go. Now at the end, we're going to print out hash map. 0 go to 1, 1 is equal to 2, 2 go to 2, 3 go to 3, and then 4 is equal to 8. 4 is equal to 8. Maybe I, n, hash map at n. Yeah, I think I have this backward. Hash map at I is equal to n. Actually, unless it's I comma n comma I. Run it. Okay, so now we're in the end. We're gonna do nums at for I in range of nums, length of num, length is equal to, okay, let's do n is equal to length of nums. So we can do in range of n, nums at I is equal to hash map at nums at I. Now we return nums, and we should get the right answer. Output 0, 2, 2, 3. That's not right. Okay. Hmm. They all three. Oh my god. Okay. So, you guys convert it to a set first and then do that? Or do I have not to do that? Unless there's a faster way. Okay, how much time do I have left? I have 5 minutes left. Yeah, I'm just gonna do a brute force approach here with of an operation. So it's gonna be for I in range, for C in range, for I in range, and length is equal to length of nums length for J in range of length if nums at I is more than nums at J counter plus equal to 1. And this is going to be our counter. The 0 res is equal to an empty array. Res dot append counter. In the end, we're going to return counter. Okay, see that works. Counter is integer. Okay. Print counter. Oh, res dot append counter, which is hang on a minute. Res. Return res. Run it. Okay. So that's over and operation, O and square operation, and I solved that pretty quickly. Okay. So that's pretty slow. Let's see what they do here. For I and not val. Duplicate. Oh, wait a minute. If duplicate, not invalid. Okay. Yeah, so it looked like they have some kind of it's called a sort num. Yeah, they sorted it first. How would I handle duplicate? How would I handle duplicate? So sorting will help, but how would I handle duplicate? Hmm. All right, I have 20 minutes left. I'm gonna try to figure this out in 20 minutes. Let's look at the solution. Duplicate is empty array, n is a length, res is the what we're going to return. Duplicate equal to sorted num. Duplicate for I in range of n, if duplicate at I not in val. What is val? Val at duplicate I equal to I. For I in range of n, res that append val at num. Okay, let's take a look at the solution. I want to print out what val is before we're done here. Print out what val is. Val is 1 at 0, 2 at 1, 3 at 3, and 8 at 4. So how did it handle duplicate? So for I in range of I, if duplicate not in val at duplicate I not in val, duplicate I, if duplicate I not in val, duplicate is hmm. So it looked like they're not. I mean, before that, I was updating it every time, right? But how do we check for I in range of? Wait a minute, how is that the same thing? So is that the only check I need? N equal to length of nums hash map is equal to an empty hash map. Res equal to this. So that's to say for I um, sorted R sorted equal to nums sorted nums, right? So for each for n comma I in enumerate nums hash map at if hash map not in hash map, then hash map at equal to I. Yeah, this is the only check I need. That's what I need for the last one. And then for I, for each, for I in range of n, res dot append nums at hash map at I. Hash map, what? Hash map. Rest of the pen hash map at nums at I. That's going to give me the index. Alright, it's going to give me some parenthesis problem here. Yep. That's right. That's right. 0 is 8. Okay, for n, for I, comma n. 0, 8, it's 0. Okay, prints are sorted. Yeah. 1 is at 1, 8 is at 0, 3 is at 4. Oh, hang on a minute. Are sorted, not at. Okay, so now that we have that, now we can just get a loop through the first loop for I comma each in and in enumerate nums at I is equal to hash map at n return nums. That's why we're doing it in place. Okay. Holy crap. Well, that was much faster than the other one. I wonder if that's faster. So the only thing I'm missing was this check because yeah, if I didn't do that check, then it's gonna update that variable every time. So I think the only thing that my last solution was missing was that check. But now that we have that, it is the fastest solution. Beat 99.79%. Hang on, let me run it again. I want to see if I can beat the maximum amount there. Oh no, we lost some point. Dang it. The leading solution is 37 seconds. I'll run it one more time. No! I don't really need this actually. I don't really need that. So that should be a little bit faster. Dang it. Okay, I think that's good enough today. Have a good day and a good life. Goodbye.